Okay guys, today we are going to do 6-6 and solve radical equations. I want you guys to get out your book right now so you can follow along. In the book they have some good examples and it'll be a lot easier for you guys to understand. But otherwise, I think you guys will find this pretty easy and hopefully be able to get a good handle on this. So for tomorrow for class we can go over some more of the more advanced problems. So here we go. So the first thing, with solving radical equations, step number 1, isolate the radical on one side of the equation. Okay, 2, raise each side of the equation to the same power to eliminate the radical or exponent. And 3, solve the resulting equation. Okay, check your answer into the original equation when you're done. So you'll finish with an x equals something or y equals something. And if you plug that back into the original equation, it should come out evenly and you should be able to see whether or not you're right. And again, this is also on page 452 of the text. Okay, so our first one is the cube root of 2x plus 7 equals 3. I'm going to, again, isolate the radical on one side of the equation, and that's already done. Now I'm going to raise each side of the equation to the same power. Okay, so since it's the cube root, I need to raise this one to the third and this to the third. So this will end up being 2x plus 7 because raising the cube root to the third will get rid of the cube root, equals 3 to the third is 27. 3 times 3 is 9 times 3 is 27. Okay, 2x equals 20, x equals 10, and there you solved that problem. And to check your answer now, if you plug that x back into the original equation, so 2, it'll be the square or the cube root of 2 times 10 plus 7. And this is the cube. So 2 times 10 is 20, plus 7 is 27. The cube root of 27 is 3, and 3 equals 3. So that's how you can check to see if you did it right. I want you guys, part of your homework is to try these 3. So go ahead, pause the video, do these 3. We'll go over them in class tomorrow. I expect these to be done for class. So again, try these 3 to the best you can, and we'll go over it tomorrow. Okay, the second part of today is again pretty easy. It's when solving an equation with a rational exponent, meaning like a fraction, raise both sides to the reciprocal power. So what would be the reciprocal power of 3 over 2? And obviously what you can do is just multiply by 2 over 3. So if I multiply this by 2 over 3, that fraction will go away. But the question is again, you can have the same type steps as you did with the radical sign. We have to isolate the variable with the power first. So in this case, we can divide by 4 first. So x to the 3 over 2 equals 108 divided by 4 is 27. Okay, so now is when we take that next step. If I multiply this whole thing to the 2/3 and this to the 2/3, this will just become x, and this x to the 2/3 of 27 would also be 9. But if we put it in the radical form, we might be able to see it easier. So again, 27 to the cube root squared, right? So the cube root of 27 is 3. 3 squared is 9. So this x equals 9. And again, you can plug that back in, check your answer, but you should come out with equal numbers. So that's all it is with getting rid of a rational power. Okay, so I want you guys to go ahead and try this problem. Hit pause, try the problem, and then I'm going to keep speaking here and continue to do it. So go ahead and hit pause. Okay, now that you guys have done it, we're going to have x plus 2 to the 3/4 minus 1 equals 7. So again, we have to get the variable on one side, or isolate the variable. So x plus 2 to the 3/4. And then I'm going to add that 1 to the other side. Okay, and we get this. Multiply by the reciprocal. X plus 2 equals 8 to the 4/3. Again, when I multiplied by the reciprocal power on the other side, that got rid of both powers. So now again, there's different ways to do this. You can use a calculator, or if you just simply put it in to this form where you have the cube root of 8 to the 4th. Then the cube root of 8 is 2, and 2 to the 4th is 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, so you're going to have x plus 2 equals 16, and then subtract the 2, so you'll have x equals 14. Okay, and that's how you do that. Hopefully you guys got that right. If not, we'll go over it tomorrow. Again, for homework, I'd like you guys to try these problems here. Go over them, do the best you can. We'll go over them tomorrow in class, but I expect these to be done for class tomorrow. Okay, thank you. Okay, moving into extraneous solutions, all right? Some solutions you're going to get, especially using the radical sign, when they aren't actually an answer, and we call these extraneous solutions. So a couple points. Raising each side of an equation to the same power may introduce extraneous solutions, okay? Always check all solutions into the original equation to make sure they work. So the important thing here is once you get a solution, check it. If it doesn't work, then it would be an extraneous solution. If it does, then it's one of the answers. So in this case, solve x plus 1 equals the square root of 7x plus 15. Okay, so in this case, we've isolated the square root sign. Now we have to square both sides. But remember, when we're squaring both sides, we have to square the whole side. So it's going to be the x plus 1 quantity squared, okay, equals 7x plus 15, right? So now I would take x plus 1 squared would be x plus 1 times x plus 1, right, because it's the quantity squared, equals 7x plus 15. All right, now I FOIL, so fronts x squared, outsides and insides is plus 2x, lasts is plus 1. All right, and now I want to subtract my 7 and subtract my 15, so I'm going to get x squared, x squared, 2x minus 7x will be negative 5x. 1 minus 15 is going to be negative 14 equals 0. So now in this case I can factor, right? So what multiplies to 14 and adds to negative 5? And I'm going to have x minus 7 and x plus 2. And now I'm going to have that equal 0. So my answers are going to, x can either equal, now remember, since we set them to equal to 0, we do 7 minus 7, or x minus 7 equals 0. I'm going to add 7, so x can equal either 7 or negative 2, right? So now check your answers. This should get plugged back in simply. So if we use 7, look up here at the top equation here. 7 plus 1 is 8, okay? 8 equals the square root of 7 times 7 would be 49 plus 15 is 64. The square root of 64 is 8, so that works. 8 equals 8, that's good. If we use our negative 2 plus 1 is negative 1. Okay, so we have negative 1 on one side, and then equals the square root of 7 times negative 2 would be negative 14, plus 15 is 1. Negative 1 does not equal 1. So therefore, negative 2 is our extraneous solution, and 7 is our answer. Now, one of the last things we're going to do today, okay, squaring twice. When there are two radicals in an equation, you may have to square both sides twice, okay? And what this means is, if we go to the next slide, if you have to solve the square root of x plus 2 plus 1 equals the square root of 3 minus x, okay? So now, how do we solve this? Again, we want to follow our steps. So we want to get a square root sign by itself on one side, which we already have. So I'm going to square root both these, or I'm going to raise this to the second power to get rid of one of the square root signs, okay? So this is going to mean the square root of x plus 2 plus 1 squared equals square root 3 minus x squared, right? Now remember, once I square both sides, this one, since there's only one term in it, the one on the right, this equals 3 minus x. So that's good. And then over here, we're squaring the whole unit here. So that means that I'm going to have to FOIL the square root of x plus 2 plus 1 and the square root of x plus 2 plus 1. Okay? And by doing that, you'll see that that's going to come out to x plus 2 plus 2 root x plus 2. Okay, plus 1. Alright, and now, okay, I want to, again, I'm going to try to get the square root sign out by itself. So I want to subtract. So if I simplify this, I'll have x plus 3 plus 2 times x plus 2 equals 3 minus x. I want to get my square root sign by itself. So I'm going to subtract an x and subtract a 3. So I'm going to have 2 times x plus 2 equals, okay, if I subtract a 3, that's going to make 0. X minus x is going to be 0. Okay, so if I so I'm going to subtract a 3. 3 minus 3 is 0, so that's going to be 0. Negative x minus another x is going to be negative 2x. All right, and now again I want to get that square root sign by itself, so I'm going to divide by 2. So the square root of x plus 2 equals negative x. All right. Now is the step where I can, since I have that by itself, I can square it again. And now this is the hardest thing we're going to do today, so don't feel bad if you're getting a little lost. Again, rewind the video if you don't understand. But if I take the square root of both of these, okay, x plus 2, the root, square root of x plus 2 squared is just going to stay x plus 2, minus negative x squared, right? So that's going to turn into then just x squared. So I'm going to have x plus 2 equals x squared. And if I keep going, then I'm going to subtract an x, subtract a 2. So let's move this up here. X squared plus, or minus x minus 2. And then can I FOIL this out? The answer is yes, I can. I'm going to get x minus 2 and x plus 1. So x minus 2, x plus 1, and that's equal to 0. So my answers could either be 2 or negative 1. Now I want to check for extraneous solutions. So I would plug those back up top into the original equation, and you'll end up seeing that that negative 1 will not work. Okay, and that 2, so negative 1 is our extraneous solution, but 2 will work. So then 2 will be our answer. All right. So last thing for homework, try these ones here. We'll go over these in class tomorrow. Again, on page 454, there's some example problems that we did here on this PowerPoint that should help you. And good luck with this. Have a good night, and look forward to seeing you guys tomorrow. Bye.